This video is going to have some examples of definite integration with U substitution. The previous video was indefinite. You don't have to worry about the bounds, but on definite integration, for instance, if I had the integral from 1 to 3 of something that I needed to use U substitution on, then I'd have to account for this, and that's what this video is about. So here's an example of a function that I'm clearly going to need U substitution on, and the U substitution is going to be pretty easy because U would be the peanut, and the derivative of the U is 3x squared dx, which is exactly what I have out here. So this would turn into the square root of U du. Now the problem is you can't put a 1 to 3 here because x goes from 1 to 3, not U. So there are two methods. You can either go this way, or you can go another way. Okay, and the two methods are, I can either change my variables to U variables, to U limits. These are X limits. If I want to change this to U, I have to come over here to my substitution, and I say if X was 1, what would U be? So if X was 1, then U is 1 cubed, which is also a 1. It doesn't always work that way. We'll see here when X is 3, then U is 3 cubed, which is 27. So this is one method to change these bounds to U bounds, and now I have a new problem that only has U's in it, and I can say the integral of the square root of U, remember, is U to the 1/2, so the integral of that would be 2/3 U to the 3/2 evaluated from 1 to 27, which would be 2/3 times 27 to the 3/2 minus 2/3 times 1 to the 3/2, which is approximately 92.864, or you could get an exact answer by leaving this in radical form. Like 27 to the 3/2 is 27 times the square root of 27, which would reduce, because the square root of 27 has the square root of 9 in it. So you could go through that long procedure doing that, or get a decimal answer if it didn't matter. Okay, so that method is to say, let me change these bounds to U bounds, and then just work the whole problem with U's in it. The other way is to not change them and leave the bounds totally off. Finish this problem just like the indefinite way. So this would be 2/3 times something to the 3/2, and we do not want to leave this in terms of U, so we'll put what U is back in. So U is the same as x cubed, so this would be 2/3 times U to the 3/2, which is, in other words, 2/3 times x cubed to the 3/2. And we'll go with our original bounds from 1 to 3. And then you could substitute in a 1 and substitute in a 3. So remember, you start with the top. So 3 cubed is 27 to the 3/2 minus 2/3, stick the bottom one in, to the 3/2. And you see this is exactly the same thing. So this would be the same answer. Now, the two methods are either change them and work the problem, or don't change the bounds, but change your problem back to x's and use those x bounds. You're going to get the same answer. You're going to have to do the same computations. It's just two different ways of thinking about it. So that's running the chain rule backwards with bounds, or definite integration.